Welcome to MR.Wanyoike, the digital learning platform. In front of you is none other than Mr.Wanyoike, a chemistry teacher. In the previous lesson, we were tackling the mole concept, and I can remember very well I gave you assignment in form of 2 questions. And the first question read, as you can see, it is well illustrated on the whiteboard here. And the first question reads 34.8 grams of potassium sulfate were dissolved in 500 grams of distilled water. You are supposed to calculate the concentration of potassium sulfate in grams per liter. And the second part of that question, question number B, you are supposed to calculate the concentration of the potassium sulfate in moles per liter. On to the calculation. You are supposed to reason out this way. You are supposed to say if 500, that is the solution, you state that if 500 cubic centimeters contain 34.8 grams of potassium sulfate, if 500 cubic centimeters contain 34.8 grams of potassium sulfate, you are expected to calculate the concentration of potassium sulfate in grams per liter. And therefore, what about 1 liter? 1 liter is equivalent to 1000 cubic centimeters, which is equal to the value of x there, the mass which should be dissolved in 1000 over solution is the one which we are asked in part Roman 1 of the question. And therefore you cross multiply, you'll get the value of x as 1000 cubic centimeters. You multiply by 34.8 grams, then you divide by 500 cubic centimeters, and by this one you can cancel this, you'll get 2, and therefore 2 you multiply by 34.8, and therefore you can see it is well illustrated in this calculator here. 34.8 you multiply by 2, you are supposed to get 69.6, and therefore this becomes 69.6 grams. And therefore in our first question, the first part of the question, as you can see here, it is well illustrated. The question asks the concentration of potassium sulfate in grams per liter, and therefore this is the amount of potassium sulfate in grams which are supposed to be dissolved in 1 liter of a solution. And therefore, how do we write the concentration? The concentration now becomes concentration of potassium sulfate. Potassium sulfate becomes 69.6 grams per liter. And therefore the first, as far as the first part of the question is concerned, that is how you are supposed to calculate. That is how you are supposed to calculate, so that you can see the answer is 69.6 grams per liter. When we come to the second question, you are expected to calculate the concentration of potassium sulfate. I'm going to rub this one so that I can guide you on how you are supposed to get for the part 2 of the question. And therefore you are supposed to ask yourself, the first part of the question, the answer of the first part of the question, we have found it as 69.6 grams per liter. That is the first part of the question. What about the solution to the second part of the question, Roman 2, and that is the concentration in moles per liter? And what you're supposed to do, you're supposed to write morality, that is the formula, is equal to concentration in grams per liter. You divide by RFM. That is exactly what you are supposed to use. And as far as RFM is concerned, and we can come up with RFM of potassium sulfate RFM of potassium sulfate. Remember, potassium is given, the relative atomic mass is given as 39, and how many potassium atoms are there in potassium sulfate? There are 2, so you will say 2, you multiply by 39, then you add 32, because there is sulfur, and therefore sulfur, the relative atomic mass of sulfur is 32, and then you add 4, you multiply by 16. Why 16? Because there are 4 atoms, of oxygen, and therefore every atom of oxygen has a relative atomic mass of 16, and therefore the total mass from the calculator, I can come up with the total mass, and therefore I'm going to start with potassium. There are 2 potassium, then you multiply by 39, then I add 32 because of sulfur, then finally I add 4, I multiply by 16 because there are 4 atoms of oxygen, and each atom of oxygen has a relative atomic mass of 16, and therefore the total becomes 174, and that is exactly what I'm going to write here as RFM 174. After having gotten that as the RFM, I'm going to get the morality, and the concentration in moles per liter is the same as morality, and therefore I'm going to write the concentration which I got in grams per liter, which is supposed to be 69.6 grams per liter. Remember, there is per liter here, there is an omission, and you are supposed to divide by 174, and after dividing, that is 69.6, I divide it by 174, I'm supposed to get 0.4 as the answer, and therefore our morality becomes 0.4 moles per liter. In other words, you can write it as 0.4 capital M, and therefore that becomes the answer of our second question. That becomes the answer of our second question. So you can see in this question, the question reads very well and clearly. You can see it is well clear here. 34.8 grams of potassium sulfate were dissolved in 500 cubic centimeters of distilled water. Calculate the concentration of potassium sulfate in grams per liter. You can see I calculated that, and the value which I obtained was supposed to be 69.6 grams per liter. That is the first part of the question, and I explained that one. Then I erased so that I could have come up with a space for the calculation of the second part of the question, Roman 2. And as far as the Roman 2 is concerned, there is a formula which I've introduced to you, and the formula is given by morality. Then morality is equated to the concentration of the solution, that is the concentration of potassium sulfate in grams per liter. Then you divide by RFM, and remember, RFM is not a new name, new word. I have been using the relative formula mass to represent the relative formula mass, that is the summation of all the relative atomic masses of all atoms that are contained in a particular compound, and in this case this compound is potassium sulfate. And having said that, I have guided you on how to get the relative formula mass. You can see the relative formula mass of potassium sulfate. I took 2, you multiply by 39 because potassium, there are 2 potassium, you multiply by 2, you multiply by 39, then you add that 2 because in the compound there is only 1 sulfur, and the relative atomic mass of sulfur is 32. Then you add 4, you multiply by 16 because there are 4 atoms of oxygen in the compound, and each atom contains a relative atomic mass of 16, and therefore the entire relative formula mass of the whole compound becomes 174. Then having calculated that, then we quit the morality with the formula which is given as grams morality is equal to grams per liter. Then you divide by the RFM, and therefore remember in part 1 of the question we calculated the concentration of this potassium sulfate in grams per liter, and the answer was 69.6. Then you are supposed to divide by RFM, which is 174, and the answer becomes 0.4 moles per liter. And that moles per liter, you can just indicate a symbol capital M, which stand for the molarity in moles per liter. The capital M is the symbol for molarity. On to the second question. I'm going to take you through this question. Can remember this is the assignment which I gave during the previous lesson, and I saw it good to cover it so that you can mark on your for your own wherever you are, so that you will be in a position of understanding whether you followed the right procedure as a result of the answer which I'm going to give you here. That is the one which will gauge you to know whether you did it correctly, or you need any assistance in this particular question. So in question number 2, there is a bottle containing nitric 5 acid, has a label with the following information. The first information is the density is given as 1.44 grams per cubic centimeters, and the second piece of information is relative formula mass is equals to 63, and lastly there is percentage of purity of the acid is given as 65. And the first part of the question, you are required to calculate the concentration of nitric acid in moles per liter. You are supposed to calculate the concentration of the acid in moles per liter, and therefore as far as the second question is concerned, you can see question 2 very well. You can see question 2, it is well highlighted very well. And the first we are going to calculate the first part of the question, and the first part of the question is you are supposed to read it as calculate the concentration of nitric 5 acid in moles per liter. So what you're supposed to do, you're supposed to write this question to analyze this question, and therefore the first part of analyzing the question, as I guide you on the whiteboard, the solution to it becomes you're going to write it as the solution to this becomes I'm going to guide you on how you are supposed to indicate it, and you're supposed to write a solution to this question as the solution to this question as mass. You look for mass of nitric 5 acid, that is NHO3, and the mass in one cubic centimeters. So you are supposed to refer to the mass as far as 1 cubic centimeters is concerned. In 1 cubic centimeters is equals to you can take the volume density, you multiply by volume, because mass is always equal to density, you multiply by volume. And after writing that you are supposed to indicate density is given as 1.44 grams per cubic centimeters. Then you multiply by volume, 1 cubic centimeters, and therefore the answer becomes 1.44 grams. So you can see it is well illustrated there. You can see it is well illustrated there. And as far as this volume is concerned, we have used a volume of 1 cubic centimeters. And what about mass? You ask yourself, what about mass of nitric 5 acid in a thousand cubic centimeters? What about that? So you are supposed to write if 1 cubic centimeters contain a mass of 1.44 grams, what about 1,000 cubic centimeters? You are supposed to get the value as x, and therefore x you will get it as 1,000 cubic centimeters. You multiply by 1.44 grams, then you divide by 1 cubic centimeters, and the answer becomes 1440 grams. And therefore that is the total mass of nitric 5 acid, including the impurity. And therefore what about, you ask yourself another question, what about mass of nitric 5 acid, mass of nitric, or we can say when it is pure, of pure nitric 5 acid, of pure mass of pure nitric 5 acid, and therefore the answer becomes what? You can see that in the previous information which we were given, as far as the question is concerned, you can see that the question is the purity. There is a piece of information here. The percentage purity is supposed to be 65. The percentage purity is supposed to be 65, and therefore when it becomes to the calculation of mass of pure nitric 5 acid, you are supposed to say 65, then you divide by 100, because it is the percentage, then you multiply by 1440 grams, and therefore after that you are supposed to go to the calculator and you compute 65, you divide by 100, I mean 100, then you multiply by 1440 grams, and therefore you are supposed to get the answer as you are supposed to multiply by 1440. So the answer you will get it as from the calculator. It is well illustrated for you there, and the answer becomes 935, and therefore the mass reduces to 936, sorry. You are supposed to get 936 as the answer, and therefore you will write it here, 936 grams, and that is the mass of pure nitric 5 acid. That is the mass of pure nitric 5 acid. And now we ask ourselves, as far as the first part of the question is concerned, you are supposed to calculate the concentration of nitric acid. As you can see here from the question, you are supposed to calculate the concentration of nitric 5 acid in moles per liter. If the mass in 1 liter of pure nitric acid is 936, then you ask yourself, what about the morality? You will write the morality. Morality is equals to the mass in grams per liter. You divide by RFM, and RFM, as far as nitric 5 acid is concerned, HNO3, then the relative formula mass is supposed to be 1, then you add to 14, because nitrogen is supposed to be having a relative atomic mass of 14, then oxygen has a relative atomic mass of 16, then in 16 you multiply by 3, because there are 3 atoms of oxygen involved, and therefore the answer you will end up getting 48. And therefore you will take 1, you add to 14, then you add to 48, then the answer you are supposed to get, the answer for that is 63. And actually you are given the relative formula mass in the question, you can see it is given as 63. Therefore, you will immediately come to the question where you have the molarity. You will say molarity is equal to grams, the number of grams which were dissolved or in 1,000 cubic solution to make 1,000 cubic centimeters of the solution is supposed to be 36 grams. Then you divide by 63, that is the relative formula mass, and therefore the answer you will get 936. Then you are supposed to divide by the 63, and you are supposed to get 14.86. 14.86 capital M, and that is becomes the molarity in moles per liter. And therefore you can see even in the computation from the calculator, so you are supposed to get 936, then you divide by 63, which is the relative atomic mass, and the answer you will get it as 14.857. And therefore, if you round it close to exactly to 2 decimal places, you are supposed to get as 14.86, and that becomes the concentration of the concentrated nitric 5 acid. And therefore we are done with the first part of the question, and therefore we are going to go to the second part of the question. And in the second part of the question, I'm going to erase this part which we have already done. We have already done with question number 1, and therefore I can erase this part, and so that I can demonstrate very well on how you are supposed to calculate the concentration. You ask in the second question, what will be the concentration of a solution prepared by diluting 20 cubic centimeters of the concentrated sodium solution, solution to 250 cubic centimeters of the acid solution. Therefore, we will come to the concept. We will come to the concept of dilution. We will come to the concept of dilution. And as far as the concept of dilution is concerned, I think I explained it very well in the previous lesson, whereby I said that you are supposed to analyze the question, and in this case there is this question: the concentration of the concentrated sulfuric acid was supposed to be 14. We have calculated it and we have found it to be 14.81, and therefore the molarity of that acid M1 should be 14.86 capital M, and volume 1 of that acid, which is supposed to be diluted as per the question, you can see it is 20 cubic centimeters of the concentrated solution, and therefore volume 1 becomes 20 cubic centimeters. And therefore, after having written that, you are supposed to ask yourself, what about the molarity 2, and that is represented by X, and therefore volume 2. You can see that after dilution, as per the question, you can see that you are supposed to dilute it up to 250. Therefore, you are supposed to add distilled water to the original amount, which was supposed to be 20 cubic centimeters of concentrated acid. Therefore, you top it up with water up to 250 cubic centimeters of the solution, and therefore the volume 2 becomes 250 cubic centimeters, and therefore you are going to write the formula which I gave the other day, that is molarity 1 volume 1 should be equal to morality to volume 2. And therefore, morality 1 is supposed to be 14.86 capital M. Then you multiply by volume 2, which is supposed to be 20 cubic centimeters. Then you are supposed to get M2, which is represented by X. Then you multiply by 250 cubic centimeters. Then you are supposed to divide both sides by 250 cubic centimeters. You divide both sides by 250 cubic centimeters, and this will cancel out. This will cancel out, and therefore the value for X becomes, you just take your calculator, you take a calculator, and what you are supposed to do, you are supposed to calculate exactly, you are supposed to calculate, you can see it is well illustrated. It is well illustrated in the question. You are supposed to calculate the number of moles, or in other words, the morality, the concentration of solution prepared by what is the concentration of a solution prepared by diluting 20 cubic centimeters of the concentrated solution to that. And therefore, after that, I'm going to go to the calculator and I will show you this is 14.86. I multiply by 20, then I divide by 250. You can see it is well written there, and therefore you are supposed to get the answer is 1.1888, and therefore that is becomes the answer, and therefore the answer becomes 1.1888. That is capital M, and therefore this becomes the answer to the second part of the question. That becomes the answer to the second part of the question. So you can see it is very well illustrated here that the concept of dilution is very important, especially this formula here, which I'm underlining. This formula here is very important. This formula is very important, and therefore, having calculated the concentration in moles per liter of the concentrated acid, and having gotten the answer is 14.6, as you can see from our calculation here, the concentration we obtained it as 14.86. And therefore, after getting that, that is the concentration of the concentrated acid. And the volume of the concentrated acid which was used was supposed to be 20. But the unknown information in this question is the concentration of the diluted acid after adding distilled water. So you find that there is more water, exactly 480, 400 and not 400 actually, supposed to be 250. You subtract 20, and therefore you are supposed to get 230, meaning that 230 cubic centimeters of distilled water was added to 20 cubic centimeters of the concentrated sulfuric acid to make the diluted solution. And therefore, the concentration of the diluted solution after equating M1, V1, M1 is the morality of the concentrated acid, V1 is the volume of the concentrated acid. You equate it with the morality of the diluted, resulting diluted solution, and also V2, that is the volume of the resulting diluted solution. And therefore, once you equate the two and you cross multiply, you will get the value of X, which represent the morality of the diluted solution. On to that point, I'm done with the assignment which was given as per the previous lesson. And in today's lesson, we are going to look on stoichiometric equation or normal equation. The work of today, we are going to be reflecting on the stoichiometric equation or normal equation. And the second part of our discussion today will be the Ionic equation, ionic equation. I'm going to explain on how you are supposed to form ionic equation, or I will explain what is the meaning of the stoichiometric equation and the ionic equation. To start with, I'm going to define what is stoichiometric equation. So what is a stoichiometric equation? And stoichiometric equation is a chemical equation in which the reactants and product are expressed in whole ratio numbers, all in whole number ratio in as far as the definition is concerned. So the stoichiometric equation or normal equation, this is an equation in which the reactants and products are expressed in whole number ratio. And therefore, I'm going to highlight several points which are very important, and you're supposed to note them, all of them. And these points are based on solubility of salt. And I think you covered this on book 2, that is Form 2. And as far as the point number 1 on solubility of salt is concerned, the first point highlights that all nitrate salts are soluble. So the points to remember, that is points to remember or points to note. The point number 1 is that all nitrate salts are soluble. So all nitrate salts are soluble, and I'm going to give an example of nitrate salt. We have the first one as lead nitrate. Lead nitrate is the first one. Lead has a valency of 2, and nitrate is a radical with a valency of 1. And therefore, that is the first example. And whenever you come up with any sort of nitrate, you're supposed to know it is soluble. And therefore, I can use the symbol AQ, meaning that it can dissolve in water. It makes a solution. Once it is put into water, it will form a solution. So AQ means aqueous. It stands for aqueous, and aqueous meaning that it is capable of forming or dissolving in water to form a solution. The second example of nitrate is magnesium. Magnesium nitrate. Still, magnesium has a valency of 2, and therefore the nitrate has a valency of 1, and therefore I can write AQ, meaning that it is a soluble salt. Then I can have sodium nitrate. Sodium nitrate, that is another example. And therefore, I just write AQ, meaning that it is capable of forming a solution. Therefore, once it is dissolved in water, it will dissolve. Put in water and mixed in water, it will dissolve, forming an aqueous solution. And number 2, the second point that you are supposed to remember. The second point that you're supposed to remember is that all sorts of sodium, potassium, and ammonium are soluble. So meaning that all salts of sodium, potassium, and ammonium are soluble. So meaning that an example, we can come up with the sodium sulfate. That is sodium sulfate. That is how we normally write it. So another example, we can come up with potassium nitrate or sulfate. We can talk of nitrate or sulfate because nitrate or sulfate, all, that is the formula is potassium is, remember, the symbol is K for potassium. Nitrate, since there is potassium there, meaning that it is a soluble salt. It is a soluble salt. Soluble meaning that aqueous solution. It means that whenever you write it in an equation, as long as it is a solution, you are supposed to write a state symbol of AQ, meaning that it is aqueous. It dissolves to form a solution. And another example, we can come up with ammonium sulfate. Ammonium sulfate, also I can write AQ there, and therefore that is the second point that you're supposed to remember. As far as stoichiometric equation is concerned, you're supposed to know that the solubility of salt is very important because it will be guiding you on writing the state symbols whenever the equation you are writing the equation in chemistry, because without the symbols, the state symbols, it means that the equation is not okay. And therefore an equation is okay when it is well balanced. And number two, you write the state symbols. And also the valency. The concept of valency is very important because you cannot balance it well unless you know the valence of the atoms and radicals involved. Number three, the point number three, you are supposed to know that all chloride salts are soluble. All chloride salts are soluble except silver chloride, but lead chloride is soluble on warm water. Yeah, so if you provide warm water, it means that it will become soluble. On to the examples of the chemical symbol, the molecular symbol, chemical symbol of an example of silver chloride. So silver chloride, I write it like that, and therefore it is a solid because it cannot dissolve. Then that is there is no 2 there. It is has a valency of 1, and Pb, I've already written the symbols, and therefore you're supposed to know all chloride salts are soluble. And therefore if I come up with magnesium chloride, I will write AQ. Why? Because magnesium chloride is soluble. Because there is only one exception here, that is silver chloride. However, lead 2 chloride is soluble in warm water. And number 4, the fourth point that you're supposed to remember, and remember these points are very, very important because they will also guide you when it comes to the salt, the topic of salt in Form 2. And therefore it is very, very important as far as salt topic is concerned. And the fourth point that you're supposed to put into consideration is that all carbonate salts are insoluble. All carbonate salts are insoluble. All carbonate salts are insoluble except we have sodium carbonate and potassium carbonate, and also we can include ammonium carbonate. That is ammonium carbonate. So those three salts, whenever you dissolve them, you put them in water and you stir, they will mix to form aqueous solution. So we can write these aqueous because after being dissolved in water, they will end up forming aqueous solution, meaning that they will mix with water thoroughly. The particles becomes the compound becomes dissociate into ions and evenly dissolve in the water, forming a homogeneous solution, that is a uniform solution. Except all carbonate salts are insoluble, except there is something wrong here as far as this statement is concerned. I can write it, all carbonate salt, I say all carbonate salts are insoluble. So I will write except are insoluble, except then except, I think even the statement was okay, except sodium carbonate, potassium carbonate, and ammonium carbonate. Yeah, the statement of verified it. It is very correct. Ammonium carbonate. So now we can write AQ. If they are in solution, you just write AQ because they are soluble. And any other carbonate apart from this one, that is those ones of sodium, potassium, and ammonium, meaning that you are supposed to represent them with letter S, meaning that they are insoluble. And point number five, which is very, very important, all sulfate salts are soluble. All sulfate salts are soluble, except we have lead 2 sulfate and barium sulfate, and therefore whenever you write you come across this one, you're supposed to represent them with the letter S, meaning that they are insoluble. That is lead 2 sulfate and barium sulfate are insoluble. But the other sulfate, another example of soluble sulfate, we can have sodium sulfate, and therefore in solution you write AQ, meaning that it is soluble sulfate. Magnesium also, magnesium sulfate, you represent it with AQ, meaning that it is soluble. On to point number 6, we are going to look on base. Point number 6, this is not a salt. We can say that all hydroxides are insoluble. All hydroxides are insoluble except we have those of sodium hydroxide, potassium hydroxide, and ammonium hydroxide. So those 3 types of bases, that is hydroxide, are supposed to be soluble. So now this, when it comes to writing of the symbol in solution state, it's supposed to be AQ, but the rest, The rest, you're supposed to represent them with letter S, meaning that they are insoluble. All hydroxide are insoluble except those of sodium hydroxide, that potassium hydroxide, and ammonium hydroxide. And finally, the last but not the least, we are going to look on number 7, and that is all bases, all oxide, all oxide are insoluble except those of sodium oxide, and this is aqueous. When you put it in water, distilled water, it will dissolve. Then we have potassium. When it is in solid state, after putting it in water, it will also dissolve, and therefore that is aqueous. And therefore ammonium hydroxide, ammonium oxide does not exist, and therefore in point number 7 we are not going to consider the ammonium oxide, because ammonium oxide does not exist. Having written all these points are very, very important in this topic, because they will be guiding you, especially when we comes to the next part of the subtopic, that is ionic equation. This information is very, very important because it will guide you on the type of the part of the compound which will dissociate when placed in water, and therefore it becomes very, very important when we come to the subtopic of ionic equation. And therefore we will be referring this when we come to ionic equation, and therefore put it in mind that this point you are supposed to memorize them and you understand them each after the other one, so that you can have a very smooth learning or progress in this topic of the mole concept. On to the example number 1. I'm going to give an example number 1, and the example number 1 which I'm going to give, there is a question. You are asked to example 1. There is a question here of example 1 of stoichiometric equation or normal equation. You are told you write an equation of the reaction between magnesium sulfate. Write a balanced stoichiometric equation of the reaction between magnesium sulfate and lead 2 nitrate. Magnesium sulfate and lead 2 nitrate. Nitrate solutions. So now what is the how do we write this the equation? How do we write the equation? And therefore as I said previously, I said that valency, the knowledge of valency, is very, very important. And what you're supposed to do, you're supposed to write the magnesium sulfate, and because it is a solution, you refer to the points which I have already discussed in this question. And the point number 5, I said that all sulfate salts are soluble except those of lead sulfate and barium sulfate, meaning that magnesium sulfate is soluble, and therefore I'm going to write AQ. Then I add it to lead 2 nitrate, lead 2 nitrate. Then I'm supposed to get magnesium nitrate then lead sulfate. And remember, sulfate, I said lead sulfate is an insoluble salt, and therefore I'm going to put it S here. The symbol is S. Nitrate, all sorts of nitrates are soluble, therefore I put AQ. And here lead nitrate is a soluble salt, so AQ. And magnesium sulfate is also a soluble salt. And therefore, having done that, I'm going to check the reactant sides and the product side. And you can see how many magnesium ions are on both sides. You can see magnesium is 1, and also on the other side is 1, meaning that magnesium is well balanced. And what about nitrate radical ions? There are 2 here, and on the other side also there are 2, meaning that nitrate ions or radical are balanced on both sides. Then sulfate, we have 1 sulfate ion on this side, and here we have another sulfate ions on the other side, meaning that our equation in this case is well balanced. So that is the first part of the question, and therefore it means that the knowledge of radicals, the knowledge of valency, and the knowledge of coming up with these points, of highlighting these points, is very, very important, so that you can establish on how this kind of reaction will take place. In our example number 2, I can write example number 2 here. Example 2. In example number 2, I'm going to come up with the reaction between metal and acid. The reaction, for example, write the equation of reaction between magnesium metal and dilute hydrochloric acid. And therefore magnesium metal is written like that. Then it is a solid. Then you react it with dilute hydrochloric acid. Then you will get magnesium chloride like that. Then hydrogen gas is also displaced. In the process you will get hydrogen gas, and this is magnesium becomes magnesium chloride. It is a solution, it is aqueous. Remember I said that all chlorides are soluble except those of silver, and therefore is the question balanced? The answer is no. Why? Because on the product side we have 2 chloride ions, and on the reactant side we have 1 chloride ions, and therefore I will put a 2 here, so that we can have 2 hydrogen on both sides, and we have 2 chlorides on both sides and 1 magnesium on one side, and therefore the equation becomes well balanced. Having said that, I'm going to give another example. Example number. I'm going to give another example, and example number 3. I'm not going to delete these points because they are very important in this particular topic or subtopic. And as far as the part example number 3 is concerned, I'm going to give this question, and the question reads, the reaction, you write an equation of the reaction. Example 3, you are required to write the reaction, the equation. Write the equation of the reaction between sodium hydroxide and another the reagent included is dilute HCl, that is hydrochloric acid. And therefore, what are you supposed to do? As far as this question is concerned, you are supposed to be very, very keen. You are supposed to be very, very keen. You know that the reaction between a base and acid, you are supposed to get a salt and water, and you're supposed to write, I can write the general equation, that is base plus acid. You're supposed to get salt plus water, and therefore that is very, very important to note that. And this type of reaction is what we refer to as neutralization. And therefore the base in this case is sodium hydroxide, and you add it to dilute hydrochloric acid in this case, and you are supposed to get salt by the name sodium chloride plus water molecule. And therefore, having said that, you can look whether the equation is balanced, and also you write the state symbol. This is a solution, this is also a solution, and this is a liquid because water, it is in liquid state. And sodium is balanced on both sides, so you can see that there is one sodium on both sides. Also oxygen, there is only one oxygen on both sides, and you can see hydrogen there too. There is one hydrogen for sodium hydroxide, one hydrogen in hydrochloric acid, and on the other side also there are two hydrogen, and therefore the equation is well balanced. The equation is well balanced, and that is how you write that. So the stoichiometric equation in this case becomes as it is illustrated on the whiteboard. Then we come to example number 4. Example 4. And in this example 4, I'm going to give a reaction between carbonate and dilute acid. So I'm going to give a reaction between a carbonate and carbonate, a reaction between you write the equation of reaction, equation of the reaction between calcium carbonate and dilute acid. So as far as carbonate, that is solution, as far as carbonate and acid, dilute acid is concerned, that is dilute acid is concerned, you're supposed to get a salt, and you also get carbon 4 oxide, and you get water in the process. Water is also produced, and therefore there are 3 things which you are supposed to obtain, that is salt, carbon 4 oxide, and water. And therefore, as far as this example is concerned, we have dilute acid, and this dilute acid, i.e., we can come up with HCl, that is aqueous. So in our question, we can be given HCl, dilute hydrochloric acid, and therefore I'm going to write calcium carbonate plus dilute HCl, that is aqueous. Then I'm supposed to get, remember this one carbonate can be solid, and therefore I will get calcium what? Calcium chloride. Then you get carbon 4 oxide, and there is water molecule. Then you ask yourself, is calcium balanced on both sides? The answer is yes, because there is only one calcium on one side, on both sides, that is the reactant side and the product side. Then what about the carbon? The carbon, is it balanced? The answer is yes also. Why? Because there is only one carbon here, and also there is only one carbon here. what about the number of the number of chlorine? The chlorine atoms are not balanced, and therefore I will put 2 here in front of HCl. I put a 2 so that it reads 2 molecules of hydrochloric acid, and that is 2 hydrogen and also 2 chloride in that case. And you can see that chloride's ions are balanced on both sides. There are 2 on both sides, and also hydrogen becomes balanced because on both sides there are 2 hydrogen, and therefore that becomes a balanced stoichiometric equation. On to the next example, we can come up, remember, as far as example number 4 is concerned, we have carbonate reacting with dilute acid, and therefore the name of the salt depends on the type of the acid used. For example, you can work the same example with a different acid. For instance, I can come up with calcium carbonate. I react it with dilute sulfuric acid, and therefore I'm going to get a different salt, and in this case I'm going to get calcium sulfate. But remember, as far as this equation is concerned, you can see that calcium sulfate is a soluble salt, and therefore since it is a soluble salt, you can just write it, that is calcium sulfate, and in the process you will get carbon dioxide, and also you get water. That is how you are supposed to come up with. So you have calcium carbonate plus sulfuric acid, you will get calcium sulfate, carbon dioxide, and water. And therefore calcium is balanced on both sides, carbon is balanced on both sides, hydrogen is also balanced on both sides because there are 2 hydrogen on both sides. Sulfur, there are 2 sulfur on both sides. And how many oxygen are there on both sides? Oxygen are 7. And what about 7 on the reactant side? That is 3 plus 4, that is 7. What about on the product side? We have 4 plus 2, that is 6, plus 1 because of water molecule. You will end up getting 7 also, and therefore this stoichiometric equation is well balanced, and therefore the name of this salt is calcium sulfate. And therefore this calcium sulfate, this is aqueous. You can write aqueous there, and this is aqueous. This is you can write it as a solid, and this is aqueous in the first one. This is a gas, this is a gas, and this is a liquid. This is a liquid, and this is aqueous. So that is how you, for example, in example number 4, I have decided to change the type of the acid and use dilute sulfuric acid, and you can see in this example I have gotten a different type of salt. In the first case I got calcium chloride, and you can see that calcium chloride, it is supposed to be written CaCl2 because calcium has a valency of 2. What about calcium sulfate? In the second equation, calcium sulfate is supposed to be written CaSO4. Why? Because calcium has a valency of 2 and sulfate has a valency of 2 also, and therefore it becomes calcium sulfate as it is written on the white board. On to another example, that is example number 5. I'm going to give more example, example 5. And I'm not going to delete the 7 points because I said the 7 points are very, very important as far as this topic of stoichiometric and ionic equation is concerned. And I'm going to give the example number, next, that is question number 5. And in this example number 5, I'm going to come up with a different question, that is the reaction of between hydrocarbon and acid. The reaction between hydrogen carbonate and dilute acid. An example, I can come up with write the equation. The question is write, e.g. write, the question is you're supposed to write the equation of the reaction between a hydrogen carbonate like sodium hydrogen carbonate and dilute hydrochloric acid, chloric acid and hydrochloric acid. And what are you supposed to do? You're supposed to write the reactant side, that is sodium, that is the solution to it, sodium hydrogen carbonate, that is you can write aqueous. Then you react it with dilute acid, that is dilute acid, that is hydrochloric acid, HCl, aqueous. So what are you supposed to get? You're supposed to get sodium chloride plus carbon 4 oxide plus water. In the process you will end up getting water, and therefore this is a gas, this is a liquid, and this is an aqueous solution, because we said in our point number for the chlorides, the point for the chlorides, you can see point number 3. I said that all chlorides salts are soluble except those silver chloride, but lead 2 chloride is soluble in warm water, and therefore the chloride of sodium metal, that is sodium chloride, is soluble, and that's why I'm writing it as NaCl. So that is how you're supposed to write it. And after that you ask yourself, is our equation balanced? So there is one sodium on both sides. Sodium is balanced. What about hydrogen? Hydrogen is also balanced because we have one here and another one here. There are 2, and on the other side there are 2 because water molecule contain 2 atoms of hydrogen. Then what about chloride ions? Are also balanced. You can see chloride one chloride ion, and also there is 1 chloride ions, and therefore it is balanced. What about carbon? Carbon is 1 on both sides, it is well balanced, and therefore oxygen also, there are 3 on both sides. So you can see that 2 from carbon 4 oxide and 1 from water, you will have 4. We'll have 3 oxygen atoms. And what about on the reactant side? Also there are 3 oxygen oxygen. Number of oxygen are 3 on both sides, and therefore the equation becomes well balanced, and that becomes example number 5. On to the example number 6. I'm going to check on a different type of reaction, and that is example 6. Example 6. In example 6, I'm going to give an example of reaction between metal and elements of group 7. Write a reaction, for example, write an equation of the reaction. You are supposed to write an equation of the reaction between sodium metal and chlorine gas. So what are you supposed to do? You're supposed to say sodium plus chlorine gas exists as a molecule, so you will get sodium chloride like that, and that is a solid, and here we have a solid, here we have a gas, and therefore you are supposed to get it that way. Is it balanced? The answer is no. Why? because on the on the reactant side, there are two chloride atoms, and what about on the reactant side? There is only one chloride ion, and therefore you will put a 2 here so that you can have 2 sodium and 2 chloride ions, and also I put a 2 here, and the answer, the equation becomes balanced, and therefore that is another part of the equation which will help us to understand more of stoichiometric equation. We have come to the end of stoichiometric equation, and I'm going to move to the second part of our topic today. And the topic today, we are going to look on ionic equation. Ionic equation, and therefore, as far as ionic equation is concerned, I said that the 7 points, I'm not going to wrap them so that you can take note of them, because they will not only help you understand the mole concept, but also they will help you to understand the topic of salt, because this forms the foundation or the basis of chemistry, and therefore these 7 points are very, very important when it becomes to this particular topic, and also the topic on salt. And therefore I'm going to give to write ionic, the second part of our discussion today, that is ionic equation. I'm done with stoichiometric equation, and in our discussion today, I'm going to define what is an ionic equation. And an ionic equation, this is a reaction that involves the ions to form the product, meaning that the ions react to form the product, and that is what we refer to as ionic equation. NB, it is very, very important to note that in order for you to come up with ionic equation, you must understand the concept of stoichiometric equation. And therefore, an example, I can come up with the reaction between between magnesium sulfate, sulfate and lead to nitrate. Then you are required to write. So the reaction between magnesium sulfate and lead 2 nitrate. So the equation, you write the equation. The question is write the equation of the reaction between magnesium sulfate and lead 2 nitrate. So the stoichiometric equation, you start from there, that is magnesium sulfate, then you add to lead, that is lead 2 nitrate, then you will get magnesium nitrate plus lead 2 sulfate. That is a solid. Remember, lead 2 sulfate, I've written it a letter S here with the symbol S, because I said in point number 5, I said that all sulfate salts are soluble except lead sulfate and barium sulfate, and therefore lead sulfate is insoluble. What about magnesium nitrate? All nitrate salt, I said they are soluble. From point number 1, you can see in point number 1, it is well illustrated that all nitrate salts are soluble, and therefore all nitrate salts are soluble, meaning that magnesium nitrate is a soluble salt. What about lead nitrate? Also it falls under that category of nitrates, and it means that it should be dissolved into in water to form a solution. And what about sulfate? Is also soluble, because when the magnesium sulfate and lead sulfate, here they are supposed to be solution react. So the reaction solution, that is write the equation of the reaction between the magnesium sulfate and lead to nitrate solution. That is the equation, that is the stoichiometric equation. And having written that, you are supposed to separate the ions where there is, which of the solution which is aqueous, meaning that in the aqueous solution, the ions dissociate or separate, meaning that but before we come to the dissociation or ionization or separation of ions, we must make sure that whenever you are writing an ionic equation, you must make sure that it is well balanced. So you must make sure that it is well balanced, and also you write the state symbols so that you can know the ions which will separate or which will dissociate during the reaction, so that the ions can react. Then in this particular question, you can see that magnesium sulfate is an aqueous solution, and therefore you write magnesium. First of all, it is balanced, and therefore you write magnesium with a charge 2 positive, aqueous. Then you add to sulfate, that is a radical also, with AQ. They separate. Wherever you have an AQ, meaning that it is aqueous solution, meaning that they will separate. Lead 2 positive, that is aqueous, and plus 2 here. There are 2 nitrate ions, so you have to start with 2 nitrate ions, aqueous. Then you will get magnesium 2 positive plus 2 nitrate ions, aqueous. This is aqueous, and you finally write Pb, that is lead sulfate, and that is a solid. It is in solid state. So that is what you are supposed to do. You are supposed to make sure that where you have written aqueous solution, you separate the ions, and where there is S, that is solid state, cannot be separated. A compound which is insoluble cannot dissociate when put in water, and therefore it means that a lead sulfate, it is an insoluble salt, and therefore it will not dissociate in water, it will not ionize in water, and therefore it remains in solid state. Having said that, you are supposed to look on the ions which are similar on both sides, meaning that those ions did not take part in the chemical reaction. That is magnesium and magnesium. You can see I have cancelled them. Why? Because they were not involved in the chemical reaction. And also nitrate ions happen to appear on both sides. I cancel them too. Meaning that they were not involved in the chemical equation. And therefore, I'm left with S, that is Pb, positive, aqueous, plus SO4, aqueous, 2 negative. Then I will get PbSO4, solid. And therefore, in this case, you can see that the ions which are involved in the chemical reaction is only the lead two ions and the sulfate ions, and therefore the lead ions and the sulfate ions are involved in the chemical reaction to form, they combine to form lead 2 sulfate salt, which is solid in state. And therefore it means that the two soluble salts, initially we had a soluble salt by the name magnesium sulfate salt, combined with lead, reacted with lead 2 nitrate salt solution, whereby each salt went decomposition, and therefore there was decomposition whereby the magnesium decomposed into magnesium ions and sulfate ions. On the same in the same case, the lead also separated, the lead ions separated from the nitrate ions, so that the lead ions finally combined or reacted with sulfate ions to form the lead 2 sulfate salt. And therefore the active ions in this case, or the ions which were involved in the chemical reaction, were the lead ions and the sulfate ions. And those ions which did not take part in the chemical change or in the chemical reaction are what we refer to as spectators ions. Spectators ions. So in this example, the spectator ions include magnesium ions. Another one, there is nitrate ions, nitrate ions, and magnesium ions are the spectators ions. Why? Because they were not involved in the chemical reaction. They were not involved in the chemical reaction. And that is one example of ionic equation. That is how we write the ionic equation. Now here I can write ionic equation. So whenever you are told or you are asked to write ionic equation, you just write it as Pb, that is Pb2 positive, that is the lead ions, plus sulfate ions, then you get lead sulfate salt, and that is what we call the ionic equation, so that you can remember. To enhance your memorability, you can try to use the 7 points, and you come up with two salts, especially the salts